Hey there, this is part 2 of Topic 8, Class 1, the live recording, or the recording of the speech marks live class that we didn't actually have. Now, we'll just go on a little bit about position vectors first. And they start at the origin. I mean, that makes sense that they start at the origin. So if we have, some length y, some vector r, and then, so that length there, whoops, it actually is y, that's a right angle, and that is x. So we can say that r equals xi plus yj. And the length of r is going to be as you would expect. Now, if we have an example of this, say we've got A that's 3, 5, and so that's a point 3, 5, and B, which is a point 7, 8, then we can say that the vector joining A to B is going to be OB minus OA. So we put in the numbers that we've got. OB is 7, 8, and OA is 3, 5, and we get our answer. And from that then we can say that, a bit scrunched, AB is equal to 4i plus 3j, and we could say that the length of that is square root of 4 squared plus 3 squared, which is 5. Okay, now let's do the question that is there. We need to draw a sketch showing P and Q. So P is the point 7, 8, and Q is the point, if we then draw it as a vector, out here somewhere. And B then asks us for the position vectors. So P will be 7i plus 8j, and Q will be negative 2i plus 4j. And we need to find an expression for PQ. And PQ is OQ minus OP. And that's negative 2, 4 minus 7, 8. Okay, that's negative 9, negative 4. And we can then find the length of that for part D. The length of that is going to be the square root of 9 squared plus 4 squared, 97. Like that. There's also some very interesting things that we need to look at, and these are called the direction ratio and cosines. Again, this is covered in the video. And say we've got a length 4 and 5. So the length of this P, which goes out to 4, 5, say, to match my diagram, then the length of P is going to be the square root of 4 squared plus 5 squared, which is the square root of 41. Now, the directional cosine of alpha is going to be the adjacent over the hypotenuse, which we've just worked out, which is 4 over root 41. And we call that, well, the textbook calls that L. Cos beta is going to be the the opposite over the hypotenuse, which would then be 5 over root 41, or the adjacent in the other triangle. So both of them will give us the same, and we call that M. So from that working then, we can see that L is equal to A over the square root of, if this is A and this is B, L is A over A squared plus B squared, and M is B over the same denominator. So L squared plus M squared, okay, square each of these. And, wow, look at that. That's not surprising. It's equal to 1. That's not surprising. Let's find the direction, the vectors in question 6, and find their direction ratios. So this is, and cosines, this is the one here where we've got -9, -4. So this is where we got to. PQ equals -9, -4, and that's prior, from previous, that's from slide 9. So the length of it is, we already know, and the first directional cosine is going to be, now we need to draw that really. So it was -9 in the x direction and -4 in the y direction, so it's there, and that'll be alpha between the x-axis, and beta will be between the y-axis. So the cosine of alpha is going to be -9 over root 97, and the cosine of beta is going to be -4 over root 97. Why are both the direction cosines negative? Because they're in quadrant 3, and cosine is negative. And it's just to do with the projection arms, the negative and the positive that you've got in there. Now we're going to do three dimensions. We've got r is equal to xi plus yj plus zk, or r equals x, y, and z. So the length is just going to be just an extension of Pythagoras. So question 3 over here, if we've got those 3 points, then P is going to be 9i plus j, and there's no k. Q is going to be 8i minus 3j plus 5k. I'll do that. I can't bold them. I'd really like to bold them. And R is equal to 5i plus 5j plus 5k. Now PQ is going to be Q minus P, which is just going to be 8 minus 9, which would be -1i, -4j, and 5k. And if we're going to look at QR, oops, That's going to be r minus q. And again, you can do the arithmetic. 5 minus 8 is negative 3. 5 minus 3 is plus 8. And actually, I have missed that. That should be a 7. And then 7 minus 5 is 2k. You need to find the length of PQ. So that's just going to be the square root of 1 squared plus 4 squared plus 5 squared, root 42. And similarly, the length of QR is going to be the square root of 3 squared plus 8 squared plus 2 squared, which would be 77. For question 4, you're asked to find b minus a. So that would be 2 minus 5, which is negative 3. 1 minus minus 2, which would be plus 3. And negative 4 minus 3 would be minus 7. Now, we need to be able to work in 3 dimensions as well. So if we've got r equals ai plus bj plus ck, and maybe I should do all of those, then the direction ratio, if we need to find it, is a to b to c. So then the direction cosines would just be that a is equal to, well, L equals a over the square root of all of the squares, and m is equal to b over all of them, and n is c. And this would be the cosine of alpha, cosine of beta, and the cosine of gamma. And so we would have the x-axis and the y-axis and the z-axis and some point P. In those spaces, actually I might call it A, B, and C. And then alpha is, excuse me, from the x-axis in there, and beta is from the P to the y-axis, and gamma is from, oops, I've got my axes around the wrong way, that's meant to be x, and that's z. And so x is from P to the x, sorry, alpha is from P to the x-axis, beta is from P to the y-axis, and then gamma is in there from P to the z-axis. As an example of that, we can find this now in 3 dimensions. So the length AB is going to be B minus A. So that would be -6 plus 2 minus 12. So the length of that is going to be the square root of 6 squared plus 2 squared plus 12 squared. And the direction ratios would be will be 6 to 2 to -12. That's coming from B minus A. D, we need to find the directional cosines. So that's the first one would be 6 over, well, we've already worked it out, square root of 184. The next one would be 2 over root 184. And the last one would be -12 over root 184. Then you need to show that the sum of those equals 1. Okay, so that would be 6, this is part E, 6 squared over 184 plus 2 squared over 184 plus 12 squared over 184 is indeed equal to 184 over 184, which is equal to 1. So L squared plus M squared plus N squared equals 1. Okay, here's a picture. We've got the Z, the X, and the Y. And we're told that a line is inclined at 60 degrees to the X and 45 to the Y. Find its inclination to the Z. Well, we already know L squared plus M squared plus N squared equals 1. And we're told that we can work out M. We're told enough information so that we can work out L. L is going to be cos 60, which is a half, and M is going to be cos 45, which is 1 over root 2. And now, using the fact that L squared plus M squared plus N squared equals 1, we can work out what N squared is, and subsequently N. So N squared is going to be 1 minus a half squared minus 1 over root 2 squared, which is a quarter. So N then is a half, and that means our gamma must be cos inverse of a half, which is either 60 degrees or 120 degrees. The triangle here has vertices A, B and C, etc., etc. So the length from A to B we need to find. That'll be B minus A, so it would be -2 plus 5 minus 3, which is 2, and 9 minus 2 is 7. And BC is equal to, okay, that's going to be C minus B, that's going to be 3 plus 2 minus 8, and C to A is going to be A minus C to be 1 plus 4 minus 1. Question 4 there, find a unit vector in the direction of I minus j. Okay, that's just going to be I minus j over the length of I minus j, which would be the square root of 1 squared plus -1 squared. So that would be I minus j over, I minus j over root 2. And the last thing I want to mention, hopefully I'll get time to do it, we can understand length in 3 dimensions and in 2 dimensions, but when it comes to 4 dimensions, it's a bit tricky. So we call this thing in 4 dimensions the length in 4 dimensions is called norm. So it's still easy to find out, just an expansion of Pythagoras' theory. So we can use the length of A is then going to be the square root of 1 squared plus 1 squared plus 0 squared plus 1 squared plus 1 squared, which appears to me to be the square root of 4, which is 2. And then the length of B is going to be similar, only bigger. It'll be 3 squared plus 2 squared plus 1 squared plus 0 squared plus 1 squared, which is going to be the square root of 15. And you have to find the length of A minus B. Again, we can just do that, finding the lengths, and then it would be -2 squared plus -1 squared plus -1 squared. Squeeze it in, actually, see if I can, plus 1 squared plus 0 squared. Oh, okay, so that is now equal to the square root of 7. Okay, now you should be able to do CH 14 now. I'm going to stop because I'm sure I'm going to run out of time, and I'll put this on Podia as well. Okay.